Thanks for tuning in. Hi, I'm Dirk Ducharme, Editor-in-Chief for Quality Digest and your host for this program from QDL and Hexagon TV. Today we have Joel Martin, Product Manager for Laser Trackers from Hexagon Manufacturing Intelligence, to discuss an interesting project called 3D in the D. And Joe, we appreciate you taking time with us today.
Absolutely, thank you.
Okay, so let's start right off. Why don't you just tell us just briefly what 3D in the D was all about?
3D in the D was an interesting project. It started from SME. They run a show for additive manufacturing, and it happened to be in Detroit this year. And their idea was, rather than having the additive manufacturers just print anything they wanted to show off their machines, let's do something that ties back to the city. So the concept came in to scan a number of buildings and statues and things around the city, automobiles, et cetera, and create sort of a cityscape of Detroit from additive manufacturing. So really printing back up all of these buildings and cars and statues and doing it in sort of a diorama that would represent the whole city, but tying in the scanning and the reverse engineering side all the way out to the additive manufacturing side to rebuild this whole diorama that existed at the show itself.
And what kind of things did you scan?
So it was everything from full-size buildings. I think the largest one that we did was the MCS, so the Michigan Central Station in Detroit.
Right. Yeah.
Anybody that is familiar
kind of
with
an iconic
Detroit,
building.
A very iconic building, a storied history behind it. So we scanned from the MCS all the way down to the tiger outside of Comerica Park for the Detroit Tiger. So it's about a 15-foot tall stone statue of the tiger itself. There were a couple that were sort of in between size, but that pretty much scans the gamut between ultra large all the way down to a large statue itself.
And what kind of equipment did you use? It was basically just one type of scanner and you went out and scanned a bunch of stuff?
I mean, that's what made the project interesting, especially from a Hexagon perspective, because we used pretty much everything in our portfolio. MCS, the train station, was primarily the terrestrial laser scanners. So these are things like the P40, the BLK 360, the RTC 360, all the way out to the drones. We needed aerial drone data to stitch in the roof portions that have, quite frankly, through the years collapsed and weren't even there to be able to be measured. So on the train station itself, I think we used the largest array of devices. Down to the Tiger at Comerica Park, we had an opportunity to use a brand new sensor that we had just released to the marketplace called the ATSC 600 laser tracker. It's a combination of laser tracker technology and laser scanning technology to give us a ultra high resolution scan of the Tiger at its scale as well. So really, I mean, almost every scanning type of technology through our portfolio we managed to touch or use in some way.
Now, I'm kind of intrigued with the MCS, so big building, that's a 14, 15 story tall building, something like that. So was the drone used only to scan the roof, or did it scan some of the face, or was the face done completely with the scanner?
Right, so we did the face primarily with the scanner. But
even though you're shooting up at an angle.
Correct, and this is where, due to the orientation of the building, I mean, you have roofs that come out, and that blocks line of sight to certain stories of the building. So primarily it was the roof, but for certain areas, even in the facade of the building, we used the drone data to stitch in the areas that we couldn't get a LiDAR scanner up on a roof to scan the next area. You couldn't see it, the roof physically didn't exist anymore. Right. So we used the drones in that as well. So it was both facade and the surrounding of the building, as well as the roof data as well. We actually did an interesting part where we flew the drone inside of the building to try to stitch in some of the internal data as well.
So then later on, so you take obviously two different instruments. You've got your scanner, you've got your drone with what, LiDAR, or what?
The drone was just camera.
Oh, so just camera. Okay, okay. And then you bring all this together later in software and stitch it together, right?
Yep. So we brought it together in 3D Reshaper, so in one of our high-end stitching packages, and we brought all of the software together in a unified coordinate system and turned it into what's called an STL Mesh. So it's basically a bunch of small triangles that represent the surface. And when you model a building, you've got a couple of ways to go about it. You can either use that scan data to create a perfect representation, so make all of your walls perfectly flat and all of your angles perfectly angled. But we didn't want to look at it from a theoretical standpoint, we wanted to look at it from an actual standpoint. What does this building really look like, just due to the iconic nature of the building? Right. So by creating an STL mesh, it makes it more realistic to what's truly there. You even get some of the decay at the building that had happened through the years. You even see that in the model itself.
Right. Now, I know, I mean, I'm assuming, since this is an old building, it has a lot of also, what do you call it, architectural elements to it. Correct. You know, scroll work, or what do you want to call it. were you able to scan those as well with decent resolution?
Absolutely. So it was really interesting. This was an area where using multiple technologies together became really cool. So we used the BLK and the RTC to do the large volume area in the drones.
These are scanners.
These are all the Geodesy terrestrial laser scanners,
yeah.
correct. And then we used the ATS 600, the product that I mentioned that was the combination scanner and tracker, because the resolution and the accuracy is substantially higher. This is a scanner that's really designed more for industry than
metrology work.
Absolutely, for metrology work rather than the historic side of the scanning side. But by using that scanner to do some of the scroll work and the detail work, it gave us an amazing level of resolution for reconstruction of those portions of the building.
Okay. Now talk a little bit about the Tiger. I think you said you used the ATS 600.
That's right, the ATS 600.
Now, see, I would have assumed, because the Tiger, I mean, it's big, but it's not huge.
Yep.
I would have assumed you would have gone with like a handheld laser scanner and just...
Yep, so we thought about it, to be honest.
Okay.
And when we scanned the Tiger, it was right at the release of the ATS 600. Literally within days of us announcing that technology to the marketplace, this project came up and we had the opportunity to do it. So our initial thought was to do it with a handheld laser scanner. And in the end, there were two things that drove us to using the ATS. The first was the fact that when we did the Tiger, it was February, and it was about 10 degrees outside. And no one raised their hand very quickly
Get out there with the
I would like
I
would like to stand outside for 2 hours and scan the statue. So we used the ATS, and it was fantastic. I mean, the data throughput and the ability to scan the entire Tiger. I think we did a 15-foot tall statue from roughly 10 stations as we move around the Tiger. It took maybe an hour and a half to do the scanning, and the beauty part of it is, as a laser tracker guy, I've been with trackers for about 20 years of my career, you're always doing something. You're working the scanner or the SMR or the probe, and here we set up the ATS and we programmed it to do what it had to do, and we drank a coffee in a warm truck.
Turned the heat on. Right.
Let it finish and came out and did it again. So it worked out really, really well.
Now you mentioned you mentioned 10 stations. So that is actually a little shameless plug for the ATS 600. That is kind of one of the benefits of that, right? Is you can easily move it, and it stitches together kind of on the fly.
Yeah, so I mean, you're using the tracker technology, so the ability to use an SMR or a corner cube to stitch all of that data together. And what it gives you, and this is how it ties back to that metrology standpoint. What do we care about in the metrology world? It's all about accuracy, right? So it's how do we keep the uncertainty of this survey as low as possible? So by using an SMR and traditional tracker technology to do all of our station moves, which is the difficult part in terrestrial laser scanning, which is stitching all of this data together, you end up at the close of the survey, at the close of the scanning of the statue, we had a fully complete model. It was, I mean, the level of post-processing was very little. It was just cleaning up the stray data and making it look like a good model and sending it off to the printers to let them have it.
So, because I forgot to ask you this, is what about resolution and accuracy? Well, let's just talk resolution first. So resolution on, let's say, the building versus resolution on the statue.
You know, it's interesting, and I mean, especially here, we've talked about some of these interconnectivity and 5G connection and data throughput, and I mean, it's a huge focus here at this conference. So when you look at it and you look at the train station was amazing. I mean, the group that did the survey, they were burning through terabyte hard drives like they didn't even exist. I mean, there was so much data. Now, when you look at the point-to-point resolution, like what is our true data resolution on the walls and on the roofs, it's not that big. I mean, you need a point every few centimeters or so. When we get down to the Tiger, now you start looking at needing points at sub-millimeter level to get the level of resolution that you need. But obviously the model is smaller, so you have less total points. But even there, I mean, several 100 million points, even just on the Tiger by itself, was the total scan. So it was an immense amount of data.
Well, let's dive into what was your most complex project?
Yeah, so I mean, from a complexity standpoint, I think the train station, hands down, just by the amount of scanners that we had to use, the drones, the terrestrial laser scanners, the ATS. The train station also, for me as a Detroit native, I mean, the train station closed down, I think, in the early 80s, and this is something, I mean, I heard my parents tell stories about going and taking the train out to Utah, I had never been in it.
And Ford's bought it now.
Ford's bought it now,
Okay.
and it was a really interesting because we could go in and we did all of the scanning inside. And it was my first opportunity to be inside of this
That's pretty cool.
iconic
Detroit
building
native,
as a Detroit native
yeah.
to really see it and to look at the decay and to look at what Ford has as their undertaking to bring this building back. And it'll essentially be their autonomous vehicle center. They're building a whole campus around this building. So it's great. It's great to see the city of Detroit and the rebirth and the coming up. So it was just a really fun project to work on.
So walk us through just bits and pieces of that. I mean, how long did the total scan for the building take?
So it's not quite fair because what we needed for this project was really just the exoskeleton.
Okay.
The project at hand, so Midwestern Consulting, which is one of our customers, they own a lot of the Hexagon equipment, they were the ones that actually did this full scanning for the rebuilding of the building for Ford Motor Company, and they spent, I mean, countless hours. I'm not even sure what it is, but they did every floor, I mean, it was the inside, the outside, everything. If you look at the exoskeleton, just the outside of the building, I think probably about a half a day, maybe a full day of scanning would be realistic to
Which is kind of crazy
completed.
if you think about scanning an entire building.
Yeah,
I mean,
it's still pretty quick. I mean, I was really impressed with how quick you can go when you really start to focus on what we're looking at, what are the critical features, what are we trying to achieve. The Tiger as well, like I said. I mean, it was an hour and a half maybe, and you've got a full recreation of the statue, so it can be really quick.
So, I mean, interesting projects and you know, kind of gee whiz, you know, I mean, kind of fun. Oh, hey, we scanned the Tiger at, you know, at the stadium. What is really kind of the long-term purpose of what you did? I mean, in a practical sense, what do we get out of being able to do this type of thing?
You know, I mean, I think I'll come back to the train station as an example. This is a building that was built in the early 1900s. If there are blueprints for it, they're probably not correct because it takes so long to build the building that by the time that you start to the time that you finish, things have changed, everything has been different.
Sure.
So having a true model of what exists from now the undertaking that Ford Motor Company has to rebuild this building, this is a tremendous task. And having no data to go from makes it almost insurmountable,
impossible.
absolutely. So having this data and in some sort of a catastrophic event or if something happens to be able to come back to it becomes absolutely paramount. It's where it really drives it.
Boy, you really set
Was
me
that a
up
good
for
segue?
That's a nice segue in case something catastrophic happens. Well, something catastrophic did happen just a couple of months ago, right? The huge fire at Notre Dame Cathedral in Paris, which coincidentally was a few years ago scanned with a Leica scanner. So talk about that a little bit because that really ties into everything that you've been talking about right now.
Absolutely. Again, really interesting. So there was a professor from Vassar College, Andrew Tallon was his name, and he had this vision of being able to utilize this data on some of these huge historic buildings where, I mean, we talk about the history of Michigan Central Station. You look at Notre Dame as the history there, thousands of years. And you talk about blueprints where, I mean, things, they didn't even exist, right? So, and even knowledge of how this building was built and where it started from and what was there before. So this was Professor Tallon's vision of using this data to come in. And it's an interesting story because the data that was the complete scan, when he did it, was not really like, ooh, we should do this in case something happens. No one ever thinks a catastrophic event will happen. But upon the fire became, I mean, immensely valuable as what do we do? Now we have to rebuild this structure. How do we do it? What's there to start with? And you look at some of his data from the scanning, and it's amazing, right? Because there are certain portions of the building where you can tell that the construction started hundreds of years before the construction finished, and portions are like out of plumb by over half a foot, where it's not like it's a little bit. Clearly you started something, the ground settled, the building shifted, you had to finish something, and it's nothing that would model.
And probably even construction techniques, I imagine.
Absolutely, yeah, absolutely. I mean, certain portions where even some of the columns in the building aren't straight, but they're not straight on purpose to help offset some of the weight of where this comes from. So, and there's, I mean, the really good thing is, so the data is actually public data. There is a link that your viewers can use and the Hex TV people can look at to actually go in and play with the 3D view of all of this data. And there's a great picture, one of my favorites is actually in the attic of Notre Dame, which is really where the fire started, because the wooden ceiling, they called it the forest, because it literally took a forest of trees to build this. You never see it. It's nothing that the public sees, because it's really, it's above the actual structure of the cathedral itself. Right. So some of the scans that were done in what is essentially the attic, which is of this wooden beam ceiling, give you an understanding of how, I mean, just catastrophic this really was, and right. how, I mean, you're talking about a wood timber structure that is 1,000 years old, that is, I cannot even imagine the level of blaze that happened when it went. So, but having that data to be able to come back and rebuild from it is fantastic now.
Yeah, and from what I understand, there is some conversation going on between
yep.
the Leica people and the people responsible for
yep.
Notre Dame to kind of deal with
yeah,
some of the data issues and that sort of stuff. Yeah.
Correct. Yeah, that data, which is essentially owned by Vassar,
yeah.
They've shared it, and like I said, I mean, you can even go online and look at it and play with it, and it's really interesting now, because there are companies that have put in bids, and some really crazy designs. I'm not sure if you've looked up what they've looked to do with the new roof, but everything yeah. from a new glass roof to completely redesigning and going in different directions with right. it. So it's interesting to see what people's visions are for change, whether it will go back to being true recreation of what was originally there, or something completely new.
Okay. Well, last question. So, future of 3D scanning.
Yeah.
You had a presentation today that showed some really interesting things going on with 3D scanning and additive manufacturing and so forth. But just to leave us what kind of, where you see 3D going.
Yeah, I mean, specifically in industry, it's really interesting to me to look at the tie-in between some of the architectural heritage stuff that we've just talked about and manufacturing, and looking at some of these same data. So looking at how we scan an airplane or an automobile or even a building, and what that data is used for through the life of the product, and using that data to better create and better produce products. And the whole thing drives, right? So from accuracy specs on historic preservation stuff, where we're talking about measuring every few inches, down to looking at being able to do an as-built of an aeroplane, so sure. an airplane, and having a true digital twin of that airplane, both for product lifecycle management, all the way out to, again, catastrophic events, and being able to say, hey, what went wrong, what happened, what was that model, because it's gone now. So right. how do we go back to the digital twin and use it? And all of that drives the technology that goes behind. It's how do we get more data, how do we get faster data, how do we make it easier to use so that it's not cumbersome to get data on everything that we build, and use this data to drive that whole manufacturing process.
Right. Well, Joel Martin, appreciate it.
Thank you, Derek.
Really
Absolutely.
Interesting, fascinating stuff. Thanks for joining us on QDL and Hexagon TV. And to watch additional Hexagon TV episodes, please tune in to hexagonspotlight.com. That's hxgnspotlight.com. And for Quality Digest, www.qualitydigest.com. Thanks for watching. So long.